All right, what about this function? Yes, it is also a straight line. So think about it this way. I'm just going to offer you a different way to think about it. My original graph is 1/4 x. Now notice back here. What was the slope of the original, the 2x minus 1? Well, it's 2. Up 2 over 1, up 2 over 1. What was the slope of its inverse? Up 1 over 2, up 1 over 2. This slope was 1/2. This slope was 2 over 1. So what about the slopes of the inverses? They are reciprocals. If you think about it, isn't slope y's divided by x's? So if you flip it, x's divided by y's. See how it all comes into play. So without even doing any work, what do you think the inverse of this function is? What would make that have an inverse? What's the slope of this function? Well, the slope is 1/4. Its inverse would have a slope of 4. Now this problem's a little bit more simplistic because there's no like +2 or anything that would change what this is. This will not be -2. This will not be +1/2. Okay, there's other ways to think about it when you do that. But for this one, that's all we got. Let's graph the inverse, 4x. What's the y-intercept? 0. There's no b, mx plus b. Slope is 4, which means I go up 4 over 1. I should say up 4 to the right 1, which means down 4 to the left 1 is the same thing. And that is my equation of my inverse. Okay? So let's fix that up a little bit, make it look a little bit more pretty. There we go. My original graph, 1/4 x. We'll do that in, I haven't done purple yet, have I? Okay. So 1/4 x. What's that y-intercept? Also 0. But this time the slope is 1/4. Up 1 to the right 4. Or down 1 to the left 4. And that makes our line go like that. All right, let me just kind of pretty it up there a little bit. It was great. Okay. Does that look like the inverse? Kind of noticing a pattern with these graphs I've been giving you. They kind of all look like that kind of a shape, aren't they? So those are lines, and lines typically have a similar notion to them. Okay. Again, I want to reemphasize, you can graph these any way you want. You can graph using a table. It doesn't matter. You can graph with your knowledge of the equation. That's fine. When you find the inverse, you don't have to think about what it can be. You just do the procedure. Remember what the procedure is for finding the inverse? You just take this, which is y equals 1/4 x, and switch the x's and the y's. And you see if I multiply this equation by 4, I'd end up with this. So, think about that and do it the way you'd like to. I've given you this. I'm going to make it a little crazier, but not too bad. Here's our equation. Switch your x's and y's. But I'm going to be very honest with you. You cannot solve this equation for y. This is your inverse. Now that seems weird. How am I going to graph that thing? Well, here's the easy way. You know me. Sometimes I just pick the easy way, even though it's not always the best way. It's really up to you. But I know it's going to be a parabola, right? X squared is going to be a parabola. I'm going to group these together. Where's my group? There it is. I'm going to shrink it up a little bit, kind of move it over here. Okay, let's take a chart. An XY chart. That's how I can make that line nice and straight. I learn. Okay. Let's pick some values for x and put it in here. Let's start with the middle. Let's start with 0. I shouldn't say the, well, when I say the middle, I guess the middle of the x axis, correct? But is there a middle to an infinitely long line? We'll talk about that in a later course. All right, if I plug in 0, I get 0 squared minus 0. Well, what's 0 squared is 0. 2 times 0 is 0. So I get the point 0, 0. Oh, that's a nice point to start with. Let's do 1. 1 squared minus 2 times 1. 1 squared is 1. 2 times 1 is 2. 1 minus 2 is negative 1. So we have the point 1, negative 1. All right, let's pick 2. 2 squared is 4. 2 times 2 is 4. Oh, we get the point 2, 0. Now some of you are thinking, couldn't I just factor the x out of there and known that my zeros were 0 and 2? Yeah, you could have. But the reason I'm doing a table is I want to show you about the inverse. Okay? Let's see if we plug in 3. 3 squared is 9. 2 times 3 is 6. We get the point 3, 3. Well, that's interesting. We have 2 points. We have 0, 0, and 3, 3. 2 points that are along that diagonal. Oh, this graph is going to intersect itself twice. If I plug in 4, I'm going to be way off the graph, so let's not worry about 4. Let's go the other way. What about negative 1? Negative 1 squared is 1. 2 times negative 1 is negative 2. 1 minus negative 2 is 3. And that kind of makes sense, because you know it's symmetrical. That the vertex is 0, negative 1, and it's symmetrical. Now, here's going to be something that's going to be tougher for me to do, but I'm going to do my best. Because I am going to try, I'm going to try to draw this parabola on this little pad. Did I show you this before? So I have this little pad that I'm writing on, you see? And I have my little pen. So there's no screen, so I'm basically guessing where the pen is. But you know, I'm getting good at it. Well, just lie to me, tell me I am. But here's what I'm not good at yet. It's going to be very hard for me to draw this. I'm going to try it. So I can probably do this side okay. Ugh. There's a button on this pen that I just clicked, and that minute just kept going. So let me try this again. Do I still have the pen? Yeah, okay. Not bad. Okay, don't need this. Let me try to do the other side. This is where it's going to be difficult for me. I might actually just do pieces at a time. Oh, terrible. Yeah. Guys, we're going to have to live with that, okay? I'm sorry it's a terrible parabola. For now, we'll deal with it. I'll get better later. Now, how do I graph its inverse? Well, here's my equation, but I've already figured out my points. Let me just use the points in reverse. All right, so let's use, here's the inverse. This is almost good. Almost. I'm just going to do this. This makes it easier for me. Okay. So x is 0, y is 0. I'm going to switch them. 1, negative 1. I'm going to switch them. 2, 0. I'm going to switch them. 3, 3. Well, that's easy to switch. Even if I got it wrong, it'd still be right. Negative 1, 3. Notice these points, though. This is not a function. Because 0 can't be 0 and 2. Remember, a function says every x has one y value. This is a function. X is 0, 1 is -1, 2 is 0, 3 is 3, and so on. This, I got two contradictions. 3 is 3, and 3 is also -1. Not a function, but is the graph an inverse? So here's 0, 0. Here is -1, 1. Here is 0, 2. What do you notice? All right. 1, 2, 3, 1, 2, 3. Oop, I forgot. Oh, that's a dumb point. It's actually 3, -1. 1, 2, 3, -1. All right, what do you notice about this graph? It's supposed to be a sideways parabola because it's flipped over this line. Is that flipped part a function? And the answer would be, it is not. Do you know, remember the vertical line test? I don't know if we've ever talked about it, but you might have heard about it before. So if this is something new to you, not to worry, but here's what a vertical line test is. If you take a line that's vertical, and you can hit two x values with it, it's not a function. Now this red graph is fine. Every x value has one y value. But what about that purple graph? There I'm okay. But as soon as I hit there, don't I have two x values, like there and there? I have two x values for every y value. That's not a function. Okay? It fails the vertical line test. But here's a little thing. You don't have to actually graph the function or graph the inverse to tell if it's a function or not. So guess what the inverse of the vertical line test would be? Yes, the horizontal line test. You know what, that's the same exact thing. I'm going to use a different style. Let's do this one. The horizontal line test. So look at this red one. The red one fails the horizontal line test. And what does that mean? Well, if it fails the horizontal line test, that means its inverse is not a function. Now, when I'm saying this, it's good to know, but don't worry if it's a little crazy in your head, because if something's not a function, we're going to make it a function. And that will be the next lesson. You're going to see where all this fits together. But for right now, can you graph an equation and graph its inverse? That's what you've got to be able to do. Okay? Y equals x cubed minus 5. Let's switch them. Now, we haven't talked about this too much yet, so we're going to not worry about solving this for y. You might know how, but I don't care right now if you do, because that's something we're going to deal with later. But that's the inverse. You just switch them. Now, how's the graph look? All right. Well, it's a cubic function, right? So you know it's going to be something like that, possibly, or it could just go like that. And I'll just save you some trouble. It's this one. Okay. There's only one x cubed. There's no x squares in there as well. You put an x squared and an x in there, and boom, all of a sudden, you're up and down. Okay. So, right now, we're going to worry about this. Now, there's only a few points we can actually fit on this graph. So, let's graph this. No, let's graph this one. We'll put this one over to the side a little bit. We'll just move you over here. So, I am going to make a table for this one. Okay, so my xy table. Now we're not going to be able to fit very much on here because we're cubing them. So if I take 0, 0 cubed is 0, 0 minus 5. So I get that. So all of a sudden I am just barely hitting that graph. Let's see if 1 fits. 1 cubed is 1. 1 minus 5 is -4. All right, that fits. If I plug in 2, see how cubic functions get crazy? 2 cubed is 8, and 8 minus 5 is 3. So if I plug in 3 for this, 3 cubed is 27. So I'm not fitting 322 on this little tiny graph I gave you. But I am going to be able to fit those 3 points. Even though we're not going to worry about the graph, this is here where it kind of flattens out and goes down. So we've done all those exponential graphs before, so we're not exponential, I'm sorry. We've done those polynomial graphs, so we're okay. I'm just going to try to do my best to go through there. I keep going back. I don't know why. I just got to practice more. Okay. Get that little branch out of there. All right. So that's your graph of x cubed minus 5. So its inverse, and remember your inverse would have to be a reflection across this line. So your inverse, well, if you just want to, since we already have the table, we'll flip it. So this graph would be negative 5, 0, negative 4, 1, 3, 2. Now my question to you, and you might have already formulated an answer, is, are those both functions? Does this graph here pass the vertical line test? It does. Would it pass the horizontal line test? It would. So those graphs are both functions. Alright, so let's graph these points. Negative 5, 0. Negative 4, 1. And 3, 2. So even though we didn't solve for it, where would those two graphs cross? They would cross right here wherever x and y were the same. So like about 1.8, 1.8, something like that. Okay? All right.